Hi everyone, it's Kamil, and today we are going to introduce our rebuy interval, which will help us to run multiple traders in parallel. Before we can do that, we need to iron out some issues that we left behind in the previous episodes. If you like those episodes and you want to support my channel, please leave the thumbs up and don't forget to subscribe. Enjoy! First, let's fix the initial buy price. As the trader starts, it immediately places a buy order at the current price. As that buy order gets filled, it places sell order which later also gets filled. And now the problematic part starts. Old trader dies, new trader starts, and it places a buy order at the same price as the previous trader just sold. When this gets filled, sell order gets placed. We can see that there's a problem here and we just paid a fee twice without really gaining anything. The solution is to be more clever about our buy order price. The idea is simple. Instead of placing a new buy order at the current price, we will introduce a buy down interval. So every new trader, as it gets the current price, it will calculate a smaller price by using the buy down interval and place a buy order at that price. Looking at it from the mathy side, buy down interval should never be smaller than double the fee that we are paying. All of this will get obvious as we will write some code. So let's jump into it and open the trader file and add the buy down interval to its state. Next, let's move to the callback which places the buy order. We will need to retrieve the buy down interval and the tick size from the state to be able to calculate the buy price. We will put the logic to calculate the price in the separate function, which we will write in a moment. To calculate the buy price, we will use a very similar method to the one that we used before to calculate the sell price. First, we will need to cast all variables into decimal structs, and we will simply subtract buy down % of the price from the price. The number that we will end up with isn't necessarily a legal price, as every price needs to be divisible by the tick size. Next, we will need to update the leader, as it needs to add the buy down interval to the trader's state. That finishes the buy down interval functionality. We can now focus on fixing the quantity that we left hard-coded in one of the last episodes. We will need step size information from the Binance, which we are already retrieving together with the tick size in the exchange info call. So we will rename the fetch tick size function to something more generic like fetch symbol filters. This will allow us to return other filters including step size from that function. Instead of reassigning the filters one by one into the settings, we will merge them together. Additionally, we will introduce a budget which will be shared across all traders of the symbol. Both the budget and the step size needs to be added to the state of the trader. Jumping back to the part where the trader places buy order, we can swap hard-coded quantity with the result of calling calculate quantity function, which as usual we will write in a second. For everything to work, we need to pattern match on step size and budget first. To calculate quantity, we will need to divide budget by the price, with one caveat, that it's possible that the result is not a legal quantity value. It needs to be divisible by step size. That will take care of the quantity. Moving to the next problem, we need to understand what could happen when the trader places a buy order. Currently we are placing a buy order and assuming that it will be filled by a single opposite sell order. Here we can see our buy order for 1000 units and somebody else's sell order for 1000 units. This is the case most of the time, but it's not always the case. Sometimes our order will be filled by 2 or more transactions. The easiest and the safest way to check has this event filled our order fully is to fetch the order again from the Binance. Problem with this approach is that sometimes we will run into a race condition. Let me describe it using this graphic. From the left, first we are sending a buy order to the Binance. It hangs for a while until it gets filled by 2 transactions that happened very quickly enough for us to receive both messages almost in the same moment. When our bot will handle the first one, it will fetch our buy order which is already filled. It will cause it to place a sell order, but then the next trade event will arrive and cause another sell order to be placed, and that's not correct. What we need to do is to update the status of the buy order after the first fetch, so when the second trade event arrives, we will ignore it. Let's give it a spin so it will get easier to understand. First, we need to stop pattern matching, assuming that a single trade event will fill our buy order. We need to drop quantity check. Now we can fetch our buy order to check is it already filled. Here I would like to point out that we will get the order struct instead of the order response struct that we are already working with. We will need to update our order response. This is a temporary solution that will get fixed in the future. Here we will check the status of the buy order. If the order is filled, we would like to do whatever we were doing before, but also update the trader's state with the updated buy order. We will tidy up a little bit, as with new refetched order, naming convention can be a little bit confusing. Back to the else, if order isn't filled yet, we can update the state with the updated buy order. We will now copy the header of our function and paste it above it so it will be run first. We will modify it to pattern match on the order with the filled status and ignore the event if that's the case. We need to modify the handler checking has sell order been filled as well. It needs to fetch the sell order, update local one and die only when the status was filled. This finishes the work on supporting multiple transactions per order. Now we will focus on getting multiple traders running in parallel. At this moment we have a silly code inside the leader that starts all of the traders in the same moment. All the changes we made in this episode will enable us to fix that now. Let's say that we place a buy order that got filled and the price fallen before reaching the sell level. We can see here that we missed a nice opportunity to buy more as price drops and gain as it climbs back. We will introduce a rebuy interval. Every trader that has placed a buy order and sees that the price is dropping, whenever it will drop more than rebuy interval below the buy price, it will notify the leader. The leader will then start a new trader which will place a buy order and the loop will continue until all assigned chunks will get used. To stop the traders from continuously notifying about the drop in the price, we will also introduce a boolean flag that will track has the leader been already notified. We will start by adding the rebuy interval and the rebuy notified to the trader's state. Rebuy should be placed as a last callback just before the one that ignores all the events. We will need to retrieve the current price and the buy price and make sure that we didn't notify the leader yet. We need to calculate is the current price below the rebuy interval. If yes, we will notify the leader and update the boolean flag. As usual, we will abstract calculation to a separate function that we will write in a moment. As I mentioned before, we will flip the boolean flag and notify the leader using the notify function with the dedicated atom. Now, jumping back to the leader module, we will need to add a new clause of notify function that will handle the rebuy scenario. On the way, we can get rid of starting the traders automatically by the leader on the start. We can copy the update trader state callback as a template and modify it to suit our needs. The main objective of this callback is to enforce the maximum number of parallel traders that we can run, as well as start new ones when we are still under that limit. here we come to realization that we need a fresh state for the trader in two different places in this code. So we will write a helper function that will abstract this for us. As with other settings, we will hardcode the rebuy interval and rebuy notified here for the time being and assign them to trader's state. The final change will be to add ID to the trader's state so we can use it inside log messages to give us meaningful data about what's going on. We will modify every callback to include that ID. I prepared a tiny showcase of how the rebuying idea works. I started the IEX session, loaded the observer, and this way we can see how the number of traders is growing as well as speeds are changing, which means that they are finishing their full trade cycles. This is extremely sliced version of trading session that took almost 49 minutes. If you are still watching this, you just witnessed an amazing thing, at least for me. The way that I can orchestrate the processes in Elixir, that just brings me the joy. But let's ignore that. In the next episode we will test all of this and other things, I assume. If you want to stay tuned, don't forget to like and subscribe. See you.